welcome everyone to the next in the series of RCA interviews with interesting people in the wireless industry. As most of you know, we do this every 3 months now on the second Tuesday. Matt, I'm going to give you a chance to tell us a little bit about your background.
All right. I born and raised in the Hudson Valley in New York until I was about 11, and then my father got transferred to Boulder, Colorado, moved out here, spent my junior high and high school years in Colorado. And during that time, began an interest in shortwave listening. And that interest, obviously goes into antennas and then radios and receivers and so on and so forth. And so as I got interested in that, I thought I was getting an interest in electronics. I actually joined the Coast Guard for 4 years, active duty, and got my electronics technician training in those 4 years. I went to school in Governor's Island, New York, and then I was stationed on a cutter out of San Francisco, did fisheries patrols in the Bering Sea, and then I worked at an air station in Elizabeth City, North Carolina. And during all that time, got an interest in engineering. So I came back home to Colorado State University, got a BS in electrical engineering. And my last few weeks in school, my wife found a classified ad, if you guys remember what those are, in newspapers advertising a job at WWV for an engineer, and I interviewed for the job and they were willing to take me, and that was all in 1989, and I've been here ever since.
Wow, fantastic. So why don't we just continue to go and we'll let Glenn catch up with us.
Okay.
I don't think everybody understands the differences between WWV and WWVH, so maybe you can give us a couple of minutes on that, please.
Okay, yeah, there's fundamentally they're the same. Obviously, broadcasting time and frequency standards, the standard time interval is our primary job. And obviously, for those who have listened for many years, we have the male voice announcing the time. WWVH has a female voice, Jane Barbie. WWVH does not have as many frequencies as we do. They have 2.5 megahertz, 5, 10, and 15 megahertz. And we have all of those plus 20 megahertz and 25 megahertz. So those are the primary differences, and we broadcast pretty much on the same power level for 5, 10, and 15 as they do. They broadcast 2.5 megahertz is 2.5 kilowatt or 5 kilowatts. Ours is 2.5 kilowatts. So yeah, it's other than them being in paradise and us here in the frozen north. No, I guess Colorado's not really the frozen north, but so that's the main differences.
Welcome, Glenn.
Hello, can you hear me?
Yes, we can. So we have already discussed, we had a few technical glitches. I let Matt start. So why don't we jump over to you for a moment, and why don't you give us a bio on yourself, please, because Matt has given us his.
Well, certainly, yes. My name is Glenn Nelson. I am an electronics technician at WWV and WWVB here in Fort Collins. And I've been with NIST since 1997. I've been in the broadcasting business primarily, pretty much all government, military, or government broadcasting since 1985. And wow. We've certainly have enjoyed our time here at, well, I say we, my family. It's been a blessing to work for NIST. It's a great place to work, and WWV is a fascinating place to be.
Cool. Okay, so my next question is similar to the last one, but a little bit different. So what's with WWVL and WWVH? Why do you have these other transmitters well into the lower frequencies?
Well, maybe I can give that answer a shot, Matt, if that's okay with you.
Absolutely.
Um, I can tell you that WWVL was it stemmed from experiments back in the 1950s with VLF broadcasting and using the VLF band, if you will, for frequency dissemination. And it was hoped that due to the kind of coverage or the kind of range that that signal had, that it could be useful for precision frequency dissemination. And so WWVL was originally founded in the I believe it was, I want to say 1960. The service began in a canyon west of Boulder, a place called Sunset. And this place had a valley span antenna with a transmitter and the downlead located at the bottom of the canyon. And of course, a valley span with the anchors on the mountains on either side. And it didn't radiate very much power. It wasn't a real powerful transmitter, but it could be received, the signal could be received in New Zealand. And so that was encouraging enough to actually build a transmitting facility in Fort Collins as part of with WWVL and WWVB. And so originally there were two stations at the Fort Collins site, one at 20 kilohertz and one at 60. And WWVL operated there for a time. And eventually it was determined that 20 kilohertz is just not all that suitable for the kind of precision that was desired. And probably even more so at that time, satellite time transfer became more of a possibility, and that was viewed as a better option. And so eventually WWVL was shut down around 1972, I believe.
But WWVB continues to transmit at 60 kilohertz, right?
It does.
Yep.
Yes.
And all these so-called atomic clocks that people have on their walls, they're picking up that 60 kilohertz signal. Is that correct?
That's right. Yeah, they're atomic in the sense that they receive the signal from that is ultimately could be traced to a cesium frequency standard.
Understood.
They're really radio receivers.
Right. Understood. So why don't we go to the history, Glenn? And I think that's your particular forte. We probably don't have time for a really long one, but maybe you can give us the Cook's tour of some of the history of the station, because it goes way back, I believe, right?
Yes, it does. Now I can talk about it, or I do have some PowerPoint slides that I could share. However, I want to be sensitive to everyone's time. I'd be happy just to give you a brief discussion of the history, if you like.
Let me ask a question. If you
Sure.
sent us the PowerPoint slides at another time, could we put them on our website?
Yeah, I think we could do something like that.
Okay,
Yeah.
why don't we do that, and then you just give it verbally?
Sure. Okay. Well, I can tell you that like a lot of things at NIST, WWV began as an experiment back in the well, actually the 19 teens. NIST used to be it was actually founded as the National Bureau of Standards in 1905, and the part of NIST or NBS at the time that did radio research was called the radio section. That was founded in 1913, and at that point in time, most of the radio transmissions were actually they were not broadcasts in the sense that we know today. They were more communications oriented. They were mostly radio telegraph. It was companies had big, huge installations along the coastlines or in their various countries, and this is how they communicated. And you could buy a telegram or a telegraph message. You could pay to have it sent over these radio telegraph stations. But the advent of the vacuum tube brought audio broadcasting really to the forefront. And in 1919, October 1st, 1919, actually, NBS granted WWV the call signs. So that is how the call signs came about. However, NIST had been doing radio research for quite some time by that point, but it is at that point that they started to look at the possibility of audio broadcasting, and they wanted to know, because it was not well known at the time. In fact, it was really a novelty. They were exploring, the scientists at NBS were exploring the range of a signal, an audio broadcast, compared to, say, radio telegraph. They were looking at the frequency range of how well it sounded. They were looking at possibility, well, they actually were involved in characterizing vacuum tubes and doing research on the tubes themselves. But as time went by, radio broadcasting really took off. It was an amazing time, apparently, to be in broadcasting. It was kind of like the Wild West in a lot of ways, because frequency allocations, there were a lot of stations on the air comparatively, but frequency allocations were kind of nebulous, and it was very difficult for radio stations to actually stay on their assigned frequency, to operate where they were supposed to. The concept of frequency spectrum wasn't widely known, and they certainly didn't have the capability, the equipment or the test equipment or just the calibration equipment to stay where they needed to be on their own. They didn't have a frequency standard. And so WWV was tasked with providing a frequency standard that broadcasters could tune into and calibrate their equipment to operate where they were assigned. And that service actually began in March of 1923. WWV went on the air anywhere. They had several frequencies from 200 kilohertz up to, I think, 2 megahertz. And they were on the air beginning at 11 p.m. till about 1:30 a.m. twice a month. And so broadcasters at that time, the broadcasting station had concluded their programming, but they would stick around and pick up these signals and calibrate their equipment. And that actually was the beginning of the time and frequency service that we still provide today. It actually was not a time service at that time. It was only frequency. It was a frequency service only. And over the years, WWV began to, it became more and more appreciated, widely appreciated, the service that it was providing. There were actually several other stations that provided frequency standards. There was a radio station in I believe it was Minneapolis, owned by the Gold Medal Flour Company, that broadcast frequency standards. And there was a station in Stanford University in California that also provided these services, but they were all traceable to WWV in some way. So in the early 1930s, the original station, which was located in the Department of Commerce Bureau of Standards facility in Washington, it was beginning to outgrow those facilities, and the interference that comes from operating a radio station next to a laboratory was becoming obnoxious. And so WWV was relocated to Maryland and operated at several stations there, or several facilities in suburban Maryland up until 1965. And this was at this period in the 50s and 60s, pretty much the height of WWV's popularity. It was pretty much state of the art for precision, as precise as you could get with HF propagation, time and frequency services. In 1944, it was in 1944 actually that the U.S. Naval Observatory granted WWV permission to broadcast the time of day. Up until that time, it had been strictly frequency standards, and we did have seconds pulses that we were sending out. But the USNO was charged with disseminating the time of day, and they actually transferred that responsibility for civilian use to NBS and WWV. And so, so in the 1950s and 60s, the military used our services, certainly educational purposes, universities, research, anyone who wanted a time and frequency service would tune us in. And so in the early 60s, though, the fact that WWV was located on the East Coast was becoming more and more of a problem because there were so many users on the West Coast. And so at that time, as we spoke of earlier, WWVL and WWVB were located in Fort Collins, and a new station had been built in the early 1960s there, big piece of property. And so it was decided to move WWV out to Fort Collins. And in 1966, we began operation there. And over time, though, the limitations of broadcasting a time and frequency signal at HF frequencies in the HF bands, the precision of those signals was limited because of the characteristics of HF propagation, where the way signals will bounce off the ionosphere with multiple different paths makes it difficult to be more precise than or as precise, I should say, as science was demanding at that time. And so, and it was about that time, once again, that satellites became an option for this service. There were earlier versions of time signals disseminated by satellites, but then GPS came along in the 1980s and 90s. And so WWV continues broadcasting, and our mission is still to disseminate time and frequency services in the HF bands, and we still have lots of users. But it's different. We have there are lots of folks who want an audio signal for their time of day service. There are folks who can still use WWV for navigation, even though GPS obviously is better for that. But one of the interesting recent developments, though, has been an organization called HAMSCI. That's HAMSCI. And this is a group of scientists and amateurs who are developing a system of receivers all over the country, and it's hoped eventually all over the world, that they have an inexpensive receiver based on a Raspberry Pi mini computer or microcomputer, and also a GPS board that attaches there that's able to provide a precision time reference for these receivers, and they can pick up multiple WWV signals, and all of these stations can pick up the same signal simultaneously. And so it gives a very good picture of propagation characteristics, and especially ionospheric effects of the effect of the ionosphere on broadcasting. And so these folks are taking WWV to a whole new level of research using things that were not even dreamed of years ago. So that's been an interesting development lately.
Glenn, that was great. So I don't know if this video is going to end automatically at 10 o'clock. So I'd like to open it up to questions. We've got two. Barney, if you could moderate, and I would ask our participants, if you have a question, please put it in the Q&A or the chat, and Barney will pass them on to our two guests.
Okay.
So it's,
And I guess either one of you can answer, but the first question is, when it's time to, well, how long are the current transmitters expected to last? I guess start with that part of it.
Well, I'll give Glenn a chance to rest himself here. Our current transmitters obviously going to go indefinitely as long as we can keep getting vacuum tubes and spare parts. We do have, we're operating on some surplus Navy equipment that we acquired, excess Navy equipment, FRT 96, Collins transmitters were excess several years ago, and we scooped up quite a few of those. One of the people here, the technicians, had a contact with the Navy, and so we've scooped up quite a few of those, so we'll be able to keep going on those frequencies. There's always talk of getting money for solid state transmitters that would use less power and be more robust, hopefully, and more reliable. And then VB, the same thing's true. We're always fishing around for money for solid state transmitters, but right now we're hanging in there, and they're good transmitters, 1960s submarine transmitters, or transmitters for communicating with submarines that have worked quite well for us.
So the second part of that question, it talks about when all the commercially available transmitters use digitally synthesized waveforms that do not have a deterministic propagation through the transmitter. Ever thought of that problem?
I think that has come up in the past, but it's always been so it moves so quickly through the transmitter that it's not really been an issue. And the on-time mark is considered, well, I guess the on-time mark is considered here in the building, but as long as we don't keep adjusting anything or changing anything drastically, it's fixed and shouldn't be a problem.
The next question was, any equipment, I guess in use, manufactured by General Radio Company, later named Genrad, used at WWV?
I don't know of any. Glenn, do you know? Does that sound familiar?
Yeah, don't recognize that. I don't think we have any equipment with that manufacturer.
I don't see any other questions. I'm thinking one myself. How big of a staff is at WWV?
We have 4 people here, engineer and 3 technicians. Everybody's very hardworking, very creative, and everyone works well together. And it used to be that the 2 stations had a staff at WWV 24/7 and a staff at WWVB at 24/7. But in the 1970s, they automated a lot of the activities here, and so it's been pared down to just 4 people now.
So it somewhat runs itself?
By and large, yes, runs itself. We do have, which started out as pagers. Obviously now we have cell phones. We have a monitoring service that monitors our broadcast and internal timing and notifies us if there's a problem. And just also as a parallel, sort of a secondary path, we have some National Instruments, VI, virtual instrument programs running that also notify us if there's any sort of problem.
Okay, a few more questions have popped up here. I'll start at the top of the list. Why did 2.5 megahertz go off the air?
2.5?
And that's the question.
2.5 is still on the air at full power, 2.5 kilowatts. 25 megahertz made an appearance. It went away in 1977, I think, to save electricity, and it was revived again in 2014, April of 2014, I believe. So we're coming up on 9 years, about 9 years that 25 megahertz has been back on.
Okay. Comment about recent experiments with another frequency in the lower frequency range, like 40 hertz.
Oh, 40 kilohertz. Yeah, that.
Yeah, 40 kilohertz.
Yeah, we have a new allocation. Well, actually, I think it was a resurrected allocation, and we tried 40 kilohertz on our antenna just briefly for a few minutes about 2 weeks ago. And so that's probably what people are talking about. We just did a quick experiment to see what the antenna would handle.
Comment from Australia about being able to hear the 25 megahertz signal in Australia now again.
Oh, that's great.
Any technical problems that were difficult, and how were they resolved?
One of the most difficult ones we had, and I think Glenn might have a picture of this, is in 2001, February of 2001, we did have a insulator fail. They're in line with the guy wire to one of the towers. The insulator failed, and so without that tension, the top hat of the north array pulled our most northern tower in a bend. It didn't collapse, but it bent over quite severely. And Glenn, do you have your picture?
You know, I'm looking for that now, and I'm trying to figure out how I might be able to share it.
I can grab it real quick. There it is. Let's see if I can get it in the, is that clear there? Can you see tower? And it's bending in towards the center of the array here. So yeah, that was about $1 million repair, and it took about 6 months for us to get back on the air after we fixed that. And then it failed again about 2 years later, but we knew who to contact and had spare insulators and all that, or we needed to get re-engineered ones. So replace those, and no problem since then.
Question popped up here. What is the typical Doppler shift frequency error introduced on the 10 megahertz WWV frequency?
Typical Doppler shift. That's a good question there. I don't have that number off the top of my head. I saw Dave Schwartz name pop up there. I don't know if he's been monitoring with or maybe he picked up something like that from one of the meetings, the Hamside meetings, but I don't know that off the top of my head. I don't know if Glenn knows. Glenn, come on.
Yeah, no,
There you go. Yeah, I can't remember.
Matt, someone noticed a radio on the shelf behind you.
Oh, the Sangean receiver there, yes. That just sits there up on the shelf. It's here in our conference room. It's good for monitoring if we have any sort of problems. I'm at WWVB, which is about a quarter mile from WWV, and we can listen in on the different frequencies. Someone calls and says there's distortion or a problem, or you're off the air on a certain frequency, and if I'm here in the conference room, can dial it up very quickly.
There's a question let's try to find them all here. What is the ultimate primary time source located?
That is located at the Department of Commerce laboratories in Boulder. Sounds like you're getting a tour of that place in November. So yes, that is where the primary standards are all, and they have quite an assortment of all the different standards. And now they have a fountain, F1, F2, F3 fountain, and masers. We do have a smaller time scale here at the station that we can pair to the one in Boulder. And then since they are by definition the time source, we steer our clocks to meet theirs.
Let's see, is funding for WWV stable?
It's always stable. No problem. You know, there's always talk in politics about doing away with this, that, or the other thing, but I'm not concerned. I think we're doing just fine, and no threats.
A ham type question about how many hams work at WWV?
Oh, how many hams? We're at 3 right now, 3 of the 4, and we're working on the 4th guy.
Any comments about the recent 100th anniversary of WWV?
Yeah, we've had 2 100th anniversary celebrations. One in 1919 when we got the call sign, the WWV call letters, and then Dave Swartz put on another one in just this year in March to celebrate the time and frequency, or the frequency broadcasts that began. I don't know if Dave's allowed to jump in there and say anything, but he set all that up at the museum and here on site and did a wonderful job.
Shifting gears a little bit, is there any, or what was the reason it actually was located in Fort Collins? Is there is it geographical, or is there a certain ground or characteristic that made that as a choice?
For WWV and VB?
Yeah.
Yes, that was ground conductivity seems to be the thing that comes up all the time when you read papers about the early days of the radio stations and choosing a site. Here in Colorado, there actually was like 5 or 6 different sites in northern Colorado that were under consideration, and then some poor farmer, his site was deemed the best one, and it was you know, and we're about an hour-and-a-half drive from Boulder, where the time scale is, and so they built the station here, and so it was ground conductivity seems to be the common thread when you read the papers.
Question popped up here about the antenna matching for WWVB.
Yes. Yeah, there is extensive matching. We have a transformer that converts the 50 ohm coax, 50 ohm output from the transmitters, to the 1 ohm resistance of the antenna. You know, the gross resistance is about 0.8 ohms. And then there is a large inductor in series with the antenna in the helix house, and it tunes the antenna. It's because the antenna is electrically short at that wavelength. The wavelength is 5 kilometers, and our antenna is 122 meters tall. So electrically short, and so we've had some inductance in the helix house to make up for that, and some tuning in that inductor. And then there's also a capacitive hat on top of that that adds a little more space for the antenna current to go up the down lead to spread out. So yes, we have extensive tuning system.
Questions are flying. There was one up near further up in the list. I sort of missed. What do you two do day to day?
Oh, the day-to-day stuff. Well, I'll put in my 2 cents here. I don't know if Glenn will want to add something, but in the morning we come in, make coffee, and we begin by taking readings on all the transmitters. We have clipboards. We go around, look at all the transmitters, screen currents, cathode currents, and just quickly jot down all the numbers, just see if we can spot any sort of trends or problems happening in the transmitters. And then we go into the screen rooms where the time code generators are, and we make sure the timing as reference to our time scale and to the one in Boulder is all where it should be and correct. And you know, the cesiums drift a little bit, so we can see when one's drifting and reset it, retime it, and then we you know, check for emails from users. We do RPMs in the helix house, do maintenance in the helix house, transmitters, obviously outed or damaged equipment or you know, equipment that's off the air is the priority to get those repaired, get some troubleshooting going, repair those. And you know, and it goes all the way from repairing transmitters and antenna down leads that are 100 meters long to doing something as simple as repairing swamp cooler plumbing. Glenn the other day replaced a length of leaky pipe. So he does it all. He does the lawn mowing, and we take care of the grounds here ourselves, also weed control. We have a small weather station that we send in weather reports to our to Cocoa Raws. And we've got bobcats and tractors that need maintenance from time to time, and the guys replace oil filters and do maintenance on those things. Let's see if there's anything else here. And then obviously the day-to-day things of trying to upgrade equipment, make our systems more reliable, robust and reliable. We try to add equipment that will eliminate downtime, new controllers, paying bills, training. We always have to do IT security training and safety training. So Glenn, can you add anything to that? Did I miss anything?
Oh, that was pretty good. I'm tired listening to you.
Okay, yeah.
Yeah, it's there's I was just thinking we have 14 transmitters that are active, not all operating at the same time, but with our online and backup transmitters, there's 14 of them, and they're all I think the newest one was built in 1990. So when you have transmitters of that age and that many of them, there's always something to do with those guys, either fixing them or just upgrading them or making them more reliable. And then it just goes from there when it starting at our frequency references, and then the time code generators that create the audio signal, or in the case of WWVB, the time signal, it's not audible, to the distribution, to the transmitters, to the transmission lines, to the antennas. There's just a lot going on, and there's only 4 of us. So it's always something different, it seems, every day.
You mentioned, I think, 14 transmitters. How many of those are active at a time, and are there, I assume if the ones that aren't are backups?
That is correct. We operate on 7 frequencies, 6 at WWV. That's 2.5, 5, 10, 15, 20, and 25 megahertz. And each of those, except 25 megahertz, has a backup transmitter. And so there's 12. And then we have WWVB. Did I say 14? In any case, we have WWVB, where there are 3 transmitters that operate at 60 kilohertz. So I guess that's 15. In any case, 2 of those transmitters are operating continuously, and then we have 1 in reserve. We rotate which transmitter is in reserve at WWVB. So if any of that made sense.
Someone asked what tube or tubes are in the WWVB transmitters.
So WWVB transmitters use 4 of the iMac, originally iMac 4CX 15000. It's tetrode, air-cooled. They're operated in push-pull. And each transmitter is capable of, we operate each transmitter at around 50 kilowatts forward power. And we're able to operate, we actually have 2 antennas. The reason we operate 2 transmitters is because we have 2 nearly identical LF antennas, antenna systems. And we send the same signal through 2 transmitters into 2 antennas simultaneously. And so that way we're able to actually radiate about 70 kilowatts, which for LF is pretty darn good.
In that same vein, the question is, was there a final report on WWVB reception improvement with the change to biphase encoding?
What kind of phase encode? The
Biphase is
and
what's typed.
and they're asking if there's a final report.
Yes, of the improvement because of that.
I don't know of any report. I don't think anyone did any sort of report that that discussed the improvements.
Another sort of a different direction. You said the funding seems secure. Where does the funding come from for WWV and WWVB?
Well, just through Department of Commerce, the Congress allocates money to NIST every year, and then NIST just breaks it down and divvies it up as they see fit to all of their different agencies.
There's two questions here really concerning the time standard. One is, are there any newer atomic clock methods that might replace the current cesium beam atomic clock?
Well, the current state of the art is a fountain clock, which is a vertical beam where the cesium atoms are, shot up into a tube, and then when they come to the top of the tube, I guess they hold still for just a second, and they can get a more accurate, I don't know the right word, timing of the vibration of the atom when it's at the top of the tube. As far as I know, that's the current state of the art, but they're always working on aluminum clocks and mercury clocks and all sorts of different types of clocks that have different advantages.
And does a clock like that exist at your facility, or is that somewhere else and then you coordinate yours with that clock somewhere else?
Yes, we run on cesium clocks up here. Our time scale is about 5 or 6, depending on how many are in service at the time. Atomic, cesium clocks, and then it's a big ensemble with all sorts of, the computers watch over it and monitor it and massage the numbers and average them, all the different frequencies and everything of what's come out of the cesiums, and then that's compared to the Boulder standard, which is by definition the correct time. And we just steer to that.
Is the distance from Boulder an issue, or is that put into the calculation or the adjustment?
That's put into the adjustment in the sense that we use something called common view. And this is a very common question that comes up, is how we get the time up here without some sort of delay. We actually we used to use a TV channel 7 here in Denver, where they would compare a certain line on the screen when it would begin to the atomic clock in Boulder, and then I wasn't here when they were doing it, but this is before I got here in the 60s and 70s, and they would compare up here the time that was starting, that line 10 is what it was called, and they would compare that to the atomic clocks up here, and then they would just by phone compare the data, and it would subtract out subtract out the timing of the TV station. A lot of people compare the analogy of a clock tower in the middle of town, and when it strikes 12 noon, one person on one side of town looks at his watch to see what time he has, and maybe it's 12:01, and the person on the other side of town looks at his watch and it's 11:59, and then they get together and compare their time, and by definition one of them's the right time, whoever they choose, and we can tell that there's 2 minutes difference between the clocks, so the other clock has to adjust by 2 minutes, and so the clock tower falls out of the equation. So we use GPS now, and that falls out of the equation when we compare.
Okay. Is there a publicly available number as far as what the budget for WWV is on a yearly basis?
A publicly,
I mean, is something you can tell us what the budget to run WWV is on a yearly basis?
I think including salaries, it's like $1 million a year. Glenn, do you know if that sounds right?
Yeah, that might be an old number, but it's no, I think that's an old number, Matt. I don't know what the current number is.
100 million, billion?
Probably not that much. Boy, that would be nice.
Yeah. But yeah, it's yeah, they slice it and dice it different ways with overhead, with salaries, you know, and things like that. But yeah, it's probably an old number, but at one time, you know, a few years ago, it was $1 million a year.
Hey, Barney,
Yes.
why don't we take two more questions, and then we'll call it a night. I'll finish up.
Okay, if you don't mind, I'll ask one. I don't think anything has been said about what antennas are used there.
The type of antenna that we
Yeah.
use? Well, it's called a modified sleeve. And if I've looked on the internet, Googled modified sleeve, and there's not a lot of, or just sleeve antenna, not a lot on the internet about it or in books. But it's essentially, it is a quarter wave grounded tower going up to a feed point with a quarter wave radiating element on top of it. And then it has a ground skirt coming down from the radiating point at 45 degrees, which gives the 50 ohm input to the feed point of the WWV antennas. And then the WWVB antennas, as I was saying earlier, they're electrically short. They're 122 meters long, suspended from 4 towers. And you know, the towers are grounded, and the top hat is insulated from the grounded towers. And so there's a down lead that goes down to a helix house. And like Glenn was saying earlier, we have 2 identical antennas like that for a total of 8 towers, 2 radiating antennas. One used to be the WWVL 20 kilohertz, and now it's 60 kilohertz. And we broadcast from those simultaneously, if that makes sense.
Oh, there's a short one here. Someone's asking what the electric bill is for a month.
I think that was about $500 a month. I think that was hanging on our bulletin board. We had a power bill, and I believe that's 500.
Well, John, there's 2 questions.
Great. Thank you so much, Barney. And thank you, Matt and Glenn, for your answers. This has
You're
been
welcome.
This has been a great interview. I want to remind everybody that we will put this up on YouTube within about a week. So it'll be available for posterity, so to speak, and people can review it. I also want to remind everybody that, again, we're going into Denver in November, and we're hoping to take a tour on Thursday of WWV. And we've got some other tours on Friday. One last thing, for those of you out there in Radio Land, please send an email to Amy, amy@radioclubofamerica.org, for any ideas you have about new topics or new speakers, because I'd love to interview some other people, and I'd love to have your input. Thank you, everybody. Have a good evening, and enjoy yourselves. Good night.
Thank you, John. Good night.
Good night.